completing the square. We have to solve these four types. Now, you'll notice that in 1 and 2, these are monics. In other words, there's 1 in front of the x squared. This is an even number. This is odd. And here we've got a non-monic with an even one here, a non-monic with an odd one there. They're the four types. Generally, with this, the completed square method is fantastic for this type of thing, right? Then it's sort of a bit debatable whether you use the quadratic formula for the others. But this is rather sweet. Starting off with this one, we have the x squared minus 4x. Take the 1 across the other side equals 1. Now, what I'll do here, I'll halve the coefficient there, which is minus 2. Then I'll square it, and I get 4. And I'll add that 4 to both sides. By doing that, that's the process of completing the square. And this is the perfect square, and that'll be x minus 2 all squared equals 5. And then all we've got to do is take the square root to both sides. So x equals 2. Taking the, beg your pardon, x minus 2, rushing it, equals plus or minus root 5. Then we take the 2 across the other side. So x equals 2 plus or minus root 5. That's that one done. I'm moving on. Here we do the same thing. We'll take the 5 across the other side. We've got x squared plus 3x is equal to 5. Half this number, that's 3 over 2. So it's a bit messy, isn't it? Squaring that, we're going to get 9 on 4. So we add 9 on 4 to both sides. Right, now this becomes x plus 3 over 2, all squared. That's half of that. And this becomes, that's 529, isn't it? 29 and 4. So x plus 3 over 2 equals plus or minus the square root of 29 over the square root of 4, which is 2. So x must equal, where can I put this? X equals minus 3 plus or minus root 29 all over 2, which is your final answer. Okay, these ones are a little bit harder and pretty debatable whether you use this method or you'll use the formula. Okay, but first of all, I need to make that 1, so I'm going to divide throughout by 2. So I get x squared plus 2x plus a half equals 0. So x squared plus 2x, take the half across. This is fairly easy. Half the coefficient is 1, and square it to get 1, so we add 1 to both sides. This becomes x plus 1 all squared. This becomes a half. So x plus 1 equals plus or minus the square root of a half. So x equals minus 1 plus or minus 1 over root 2. Now that's a little bit ugly, so I'll rationalise the denominator. It becomes root 2 over 2. And this becomes minus 2 plus or minus root 2 all over 2 is your final answer. That's actually correct. Depends on what the teacher wants. If you want an approximation, use your calculator to get the rest of it. But that's a much neater solution. Last one here. We're going to divide it through by 3 to make that a 1 there. So we get x squared minus 5 over 3x minus a third equals 0. We're going to take that third across to the other side. Okay, so we're going to halve this. 5 thirds times a half is 5 sixths. That's where it gets messy. Now we're going to square that, and we're going to get, that'll be 25 over 36. There. Alright, so this will be x plus 5 over 6 all squared equals, I suppose you bring out your calculator, I'll do this in my head, I'm going to multiply that, it's going to be 12 on 36, 25 and 12, that's going to give me 37, isn't it? That's 37 over 36. So x plus 5 on 6 equals plus or minus square root of 37 over square root of 36 is just 6. So x equals, taking this across, minus 5 plus or minus square root of 37 over 6. And it's sort of debatable we're going to use this method or we're going to use the formula. I think the formula in this case is probably a better option. But certainly with this one, the Cleveland square method is very, very nice. Okay, that's done.